Hi, today's task is heaters. Let me quickly read the question and I'll start solving it. Okay, so this the first one, we have houses. This is the houses, positions of houses and heaters. So we need to find a radius for the heater, so our room should be covered. For here we have two. It should be also minimum. For here, if we put the heater in the position number 2, distance between the middle house and the heater gonna be 0, between the one before the 0 house and the heater gonna be 1, and between heater under index 2 and the heater itself, the value is gonna be also the distance is gonna be also 1. So the output 1. In this case, we have 2 heaters. And and if you have a radius here, let's say start with one distance between heater and house. Zero, over here distance between that house and first heater 1. Here is the distance between heater and between this house and the first heater is actually 2, but the distance between heater and the second between the second heater and the house is actually 1. And here also distance is 0 between second heater and fourth house. So to me, this task looks like a binary search for radius, and we need, we're gonna binary search the minimum radius that will allow all the houses to be heated. The only problem is that I need somehow to efficiently so the value 10 to the power of 9, so it's going to be log 10 to the power of 9 for the binary search, plus we need some multiplied, like log 10 to the power of 9 for the multiplied by the whatever complexity of checking the radius, if it's if it will allow to hit all the houses. like current radius allowing hit all the houses. So let's take this example because I like it. Okay. So let me remap my tablet so I can okay, can draw. So we have houses. So houses, house and heaters. So the value is less than 10 to the power of 9, and the number of houters and heaters is 3. Heaters is less than or equal 3 to the power of 10 to 3 multiplied by 10 to the power of 4. So if I gonna, let's say we have a set radius, how we can efficiently check if this radius will allow all houses to be heated. So let's say we have like radius, let's say 2. If we do just simple check, like brute force, we do calculate the radius, the distance between the first heater and a first house, the first heater and the second house, a second room, the third room and the first heater, and the fourth room and the first heater. So it's gonna be like distance gonna be 0, distance between first room and the first heater, 1, distance between second room and the first heater, 2, distance between third room and first heater, and then 3, distance between fourth room and the first heater, and do the same for the second heater. So it's gonna be 3, 3, 2, 1, 0. And if you like, just take the minimum, whatever we have here. So if we take minimum between every pair, so it's gonna be 0, 1, 1, 0. Okay, and 0, 1, 1, 0. And in this case, the maximum radius gonna be just 1 in this case. Okay, so I guess, so in this case we have complexity or of, we probably don't need to do the binary search. I can see that from here. If we just do this kind of if you do this first, like brute force approach, and then take the maximum values out for the all pairs, it's gonna be output the maximum like upper bound for the radius. Yeah, but the like we build the pairs, not the pairs. We build an array of arrays, and the array index here, like array under 0 index is gonna be the distances between the room between the room number 1 and the all heaters, and then so this is the distances between room 1 and heaters, and the second gonna be the same but for the room number 2 and heaters, and the third one gonna be the distances for the between the room number 3 and all heaters, and if we take the for every array here of distances between a room and all the heaters, if we take the maximum, or no, we have to take the minimum. Take the minimum to choose, like, are we gonna to choose what's the best position, what's the best heater to hit the current room, and then so the best heater radius to hit room 1, and then best heater radius to hit room number 2, and then best heater radius to hit room number 3, and so on and so forth. And best heater radius to hit room 1, 2, and 3, and because we need to select only the one number that's gonna be the radius, heat radius for all heaters. We need to take the maximum of those values. So if you do the time complexity, so the pseudocode for this one is for a room in rooms, and for heater in for heater in heaters, do the following. For every room in rooms and for every heater in heater for the current room, I wanna subtract basically the position of room. So save the absolute value of position of the room minus position of the heater, and save it to the array. And then do this maximum minimum. So have there or of let's say you have number of heaters, it's or number of rooms, like we have heaters equal number of heaters, so it's gonna number of rooms gonna be n, number of heaters gonna be m. So in this case we'll have O of n size O of n by m, that's gonna be the size of this array. Of n by m gonna be the size of the two-dimensional array. And the complexity of this is gonna be O of n by m. And given that we're gonna save this absolute value to the two-dimensional array, and then after we do this here, so we're gonna do save the absolute value of the position of the room minus position of the heater. Save it to the let's say distances array for the room and heater, and then on this level we need to find the minimum distance or h for the h in heaters So finding the minimum is gonna be again, we need to go through all the entries and for every room, so it's gonna be O of n by m, and then on this level there's gonna be for the r, and on this level we need to find maximum for the r. And that's not to confuse, call it this mean distance for the room R, and then for the mean distance we need to to check all the room and rooms. We need to find the maximum distance between the among the best heater location for the every room, among the best distances for the best among the distance between for the current room, what's the best distance between a room and a heater. So it's going to be O of n complexity. So the total complexity going to be like, we have for this operation we have 4 in 4, so this is or n by m, and then for the finding the minimum is going to be the O of m, but we actually need to do that n times, and then finding them, so like O of m by n for the for loop plus again O of m and by n is for this minimum, so we need to do this finding minimum between m values for every room, and there are n rooms, so it's O of m by n plus O of n for finding the maximum between the min d. And so the total term complexity is going to be O of m by n, and it's if I calculate that, it's going to be 10 to the power of 10 to the power of 4 multiplied by the 10 to the power of 4 multiplied by 3. So it's going to be 3 by 10 to the power of 8. And it's not what we want here. I wonder if I can do something. So this was the first approach, brute force. I call it brute force. I wonder if I can sort the heaters. Let's see. Sort heaters and sort houses by their positions, so that we'll have this for the every house. We're gonna calculate the distance between the house and the heater. Let's say we have like 2 pointers approach. And let's say we have pointer number 1 pointing to the houses, pointer number 2 pointing to the heaters, and we need basically to, okay, this is gonna be heater, this is gonna be house pointer, and we check the distance so between house and the heater. So for the room, for the distance, the distance between house and the heater. So we calculate the distance between house first and the heater is gonna be 0, and then we're gonna move the pointer for the house, for the second house. It's gonna be 2 minus 1, and we compare it to the next heater, if it's lower or higher. If the distance to the next heater is lower than the distance to the current heater, then we do the heater pointer move, and so there are two cases: the heater on the left, heater house, and the heater on the right, division, heater 1, heater 2, and this distance, and if the distance of this heater is, let's say, smaller, it's higher than the distance of this one, then we need to jump into this heater, because if we move the house pointer, this one becomes even bigger and this one becomes even smaller. Okay, so we'll have like two pointer approach. Here, two-pointer approach, and we will move the pointer for the for every house. Gonna go through the first pointer, gonna go through all houses, and second pointer gonna go to the through the heaters, and we're gonna only move the I'm gonna 4 house. Oh, it's not houses, it's rooms. Why it says houses, heaters? That's weird. Okay, it's houses. So for every house in houses, that's going to be the pointer to the house. We need to check them if the while heater less than m and heater distance of the less than m minus 1 and the distance of the heater and the house pointer is so I wanna always move forward. So the distance of the heater, current heater and the house is greater or equal distance to the heater plus 1 and the house. I wanna move heater pointer in this case, and I need to update the well. So I minimize this distance, and I need to update the distance for the house equal the final distance of the absolute position of the heater minus position of the house. So this complexity, because it's gonna be, and then I need to find the maximum of the distances in the end to get the output. The complexity of this one is actually O of n plus O of m. So it's going to be 3 to the power 10 to the power of 4. That's the second approach. So it's 2 pointers. And I wanna think about this problem in terms of like, is there any efficient way to do this binary search for the radius? So I need somehow to efficiently check if the currently selected radius satisfies our requirement. If the currently selected radius, if the heater that's gonna have the currently selected heat radius gonna warm up all the houses. And yeah, I'll probably start programming the second approach because I cannot see it right now. Where I can do this check efficiently. So if I do the binary search and then I select the target, let's see, I select the, let's have this copied again, example. So it's gonna be, so I select the target radius doing binary search, and I need to check if is it okay, is it hits all houses. And the best I can do right now is O of n by m by doing this brute force. So the complexity of that is going to be even higher. So log, let's say v multiplied by O of n by m, whereas v is max bound for the heater radius. And it's much bigger than it's a huge number. Current computers cannot calculate it, so it's like 9 multiplied by 10 to the power of 8 multiplied by the log 10 to the power of, I guess, 8, 10 to the power of 9. So it's gonna be 81 by log 210 by 10 to the power of 8. So it's gonna be roughly 10 to the power of 9. or even 10 to the power of 10. And it's quite a big number. Okay, I cannot come up quickly with how I can improve this one check for the reuse. So I'll probably start coding the two pointers approach for this problem. Let me create the one. Okay. So I select Java. I select this one is good actually. So this one. So we have for Java kill raise first, then I'm gonna sort raise, sort houses. Arrays, sort heaters, and then I'll have heat pointer heater equals 0 and pointer house equals 0, and then I'm gonna have int result equals, let's say we have houses, pointer house minus heaters, pointer heater, and then it's going to be initial result, and then for int house and then int pointer houses for the house from 0, say you have int equals house length, and int m equals heaters length, and for the houses, if the house is as an n house plus plus, and then we do this mean distance equal houses house mass ups minus heaters okay, then we need to do while heaters pointer p heater, let's say ht gonna be 0, ht gonna be here, house 0, and then while heater plus 1, heater less than m minus 1, and we can still improve this one. Heater plus 1 is less or equal the mean distance. We're gonna update the mean distance. And then heater pointer plus 1. And then we're gonna update the result. Go max. Oh, yeah. Result. Distance and result. And then we can return result. Okay, let me quickly check if it's gonna work for our example. We have houses like this one and heaters like this one. So public void test 1, and then we'll have their array of houses, and then array of heaters, and then we try to find it expected output equals 1, and solution equals solution find reduced, and then houses heaters, and then system out and ln test 1, failed. Okay. Let's have it test 1. So let me quickly, before running that one, check if that's gonna work actually. So we'll have already sorted array of houses and heaters. So there, in this case, I have this houses, and this is gonna be heaters. So let's say we have this one, this one here. If we do the quick iterations of the first house pointer is equal 0, less than n, so we check we figure out what the minimum distance between the that one the heater and current heater pointer, and we do the heater. We have heater equals 0 initially, like initialized here, and the min d equals and result is equals 0 initially, and min d is equal between house and the heater on the index 0 and 0. It's gonna be 1 minus 1 gonna be 0, and we check the next heater, distance between the current house and the next heater, distance between the current house and the next heater gonna be and the next heater gonna be 3, so we don't move the heater pointer. We exit the loop and we update the result. It's gonna be still result equals 0. So we moved house pointer. Now house pointer is 1. We check if the distance between the current house and the current heater is, so the current distance between min d equals 1, because between current house and the current heater is going to be 1. And then while I can improve this distance, I'm gonna move a heater pointer. So heater equals 0, next heater pointer is 1, next distance is gonna be 4 minus 2 gonna be 2, and it's greater than min distance. So we exit the loop and we update the result with the distance between current house pointer and current heater pointer. It's going to be result equals 1. So we move house pointer 2. So here's 3. House pointer is going to be pointing to 3, and heater pointer going to be pointing to 1. And in this case, the min d is equals 2. We enter the loop here. We check heater pointer. Heater pointer is like 0. It's less than m minus 1. We check if we can improve the current min d by moving the heater pointer. Can we do that? Yeah, sure we can, because we can move to the 4, and then the distance is going to be 3 minus 4 by model, so it's like 1. Absolute 3 minus 4 going to be 1. So the min d, we change min d equals 1, and we move heater pointer 1 to the index 1. Then we check again if we can improve this min d, make it smaller, but we cannot, because we reached the end of the heater point for the heater pointer. We cannot improve it anymore because we cannot move it to the right, further to the right. So we stop right here. We update the result. Result equals min d in this case gonna be stay 1, and we gonna keep the result as it is. We go to the house number. We move house pointer by incrementing it. So we'll have this house 4 at position 4, and the heater at position 4, and we can update the mean distance. Calculate the mean distance is going to be 0, 4 minus 4, and I'm going to check if we can improve this min d by making it smaller, but and moving heater pointer, but we cannot move the heater pointer because it's already on the right edge, so it's already equal -1. So we exit this loop and we update the result, and this case result is gonna be 1, and we output the result. So let me quickly run that one. Run code. Okay, passed. Let me check other cases. So 1, 5, and 2. Okay, double brackets. Okay, failed. Why? Because the output in this case should be in the middle. Put the heater in the middle, like 3. So the distance should be like 2. Oh, in the middle, 3 minus 1 gonna be 3 minus. Oh, radius should be. If you put the heater on the distance 2, it can be 3. The minimum radius is gonna be 3. Yep. 1, 2, 3, 2. Expected output gonna be 1. Oh, I didn't add that. Yeah, let me think about edge cases. Here the house's length 1, minimum house's length is 1, and their minimum heater's length is 1. It can be the situation when we have an out of bounds, some kind of condition. So houses, we sorted, okay. This potentially can be, but the length is greater than equal 1, so this one is case is it. Okay, if we do this iteration, we do this, we update the result, we return the result. Okay, let me. Seems like there is no edge cases incorrectly processed. So let me time complexity. Time complexity. So here is going to be off n log n plus of m log m plus for the every house of n. For the every house, we're gonna move we're gonna have it looks like it's n by m, but actually it's n plus m, because we're gonna move a heater in the heater range only once, so it's like 2-pointer approach. So the total time complexity of this one, the space complexity. So here we sort in place, here sort in place. We have only one result value, and all this is saved here and there. It's like all of one. Yep. So let me quickly check that one, if that actually works. Oh. Okay, I checked. I checked lower bound, but I didn't check the upper bound for the edge cases. So it's for the 10 to the power of 9, so we have, like, let's say, int your max value. So the integer max value 2 to the power of 32. Uh, 2 to the power of 32. Oh, cannot calculate. Oh, how to? 10 2 to the power of 32 equals like this one. So we have like 4 to the power 4 multiplied by 10 to the power of 9, and here we have, okay, so that's fine, but actually we're gonna just thinking where the overflow is happening there. Submissions. Okay, let me wrap up. Probably I can quickly check, change it to long and check if it's gonna pass. But as of now, I cannot see where the overflow is happening here, this code. So it seems like houses we subtracted, so it shouldn't be overflow here. If we have control over the minimum, and we subtract like int from int, and like it's, let's say, 10 to the power of 9, if I'm not mistaken. Yeah, let me quickly check, change to the long and see if it's gonna work. Oh. Yeah, still the same one. So the output and actually is lower than expected. So let me add this case. We have test 4 and all this equals this one and heaters equals this one. Actually this one. Okay, as expected. Let me quickly um, and do the same for the heaters. Okay. Okay. So houses and heaters. We have array of heaters. That one 600 million. Let me read this question. Mhm. Okay, let me wrap up. I cannot find the uh, why I have this error here. I thought that two pointers approach should work here, but um, yeah, it seems like on this current case, I don't understand this error because I outputted the better radius, like it's less than expected, and like it's something less than expected, yeah, and it's not obvious to me right now why this should be the right answer than this one. Probably doing this manually, like subtracting, will help, but I'm out of time and it's fail. Yeah.